Thank you very much. And hello, everyone. My name is Artemis Karlatsidou, and I'm a lecturer in citizen science in the Department of Geography at the University College London. I would like to again welcome you to the, I don't know, it's like the 15th webinar of an online, of a series of online webinars that we organize at University College London and the People Nature Lab at UCL East, and which are funded by the Erasmus Plus project, which is called Community-Driven Digital Action, a Catalyst for Social Change in the COVID-19 Crisis. So the online webinars aim to promote citizen science, hence their name, Citizen Science for All Talks. Each Citizen Science for All event has a specific theme, and we invite world-leading experts to share their knowledge from their specific field of practice and the many years of experience that they have in this area. So in this Citizen Science for All event, we will be talking about Odour monitoring with citizen science. Citizen science has been recently defined in lay terms as the scientific work undertaken by members of the public with or under the direction of professional scientists and scientific institutions. Citizen science has seen a massive growth with hundreds of thousands of volunteers worldwide collecting data, and then a massive availability as well of relevant data collection and citizen science platforms to support the volunteers. Today, we have two speakers to discuss Odour sensing and how this can be achieved using citizen science. We will start with Rosa Arias, a chemical engineer, with over 15 years of experience in odor pollution and citizen science, as CEO and founder of Science for Change. Rosa was also the coordinator of the very successful European project Dynamical. Our second speaker is Sofia Teixeira, a research fellow in the air quality group of the Department of Environmental Sciences and Engineering from Nova School of Science and Technology, University of Lisbon. Sofia is an expert on social research in environmental questions, focusing on the issue of citizen science in atmospheric odors, developing odor monitoring programs, as well as in air quality monitoring campaigns and environmental awareness actions. Due to the limited time we have and the fact that one of our speakers has to leave a bit earlier, we will not take any questions at the end, but we will ask you to send your questions to our speakers directly on Twitter or contact them via email. So if our speakers want to put their email address or Twitter handle on the chat area for people to send their questions after the session. Thank you very much. Rosa, the floor is yours.
Thank you so much, Artemis. Let me start by sharing my screen and by thanking you for organizing this nice webinar and inviting us. Today we will be talking, as you know, about odor pollution management. I want to introduce very briefly the topic on regulation as well, because probably you are not very familiar with the issue. It's the typical thing if you are not suffering from this type of pollution. We will also present you our app to record odors, which is called Odour Collect, and also some of the results that we got in the Dynamical, the project that Artemis were mentioning. And then we will have time for some questions. So to start with, odor pollution is not just a nuisance. It's the second reason for environmental complaints after noise worldwide, accounting for around 30% of the complaints when we have the data, because usually we don't have the data. But in these cases, more or less, it's always this percentage. It is not just the nuisance that it provokes when you are receiving frequently, you are exposed to these ambient odors that are usually not nice, but it also causes headache, anxiety, stress, lack of concentration, sleeping disorders, or even increased respiratory problems. It also can happen an economic impact, for example, in affected communities in terms of tourism, for example, or the loss of property values. And it's also connected to a fall of productivity. To sum up, it affects our quality of life, and that's why it is important to take this issue into account. Traditionally, odors are managed basically through two main methodologies that are standardized at the European level. The first one is dynamical factometry. This is the first picture that you see on your right. Here you have 4 people smelling at the laboratory and trying to figure out the odor concentration of samples that are taken in the source. This means in the chimneys, in the basins, in the surface of landfills, for example, or any other smelly other sources, okay? And this is always used in the emission points. And then you can use dispersion modeling to estimate the average impact over the population. The second technique more used is the field observations. Here you have these girls on the field smelling, and this consists of creating a grid of points where you go and smell at the specific times of day throughout 1 year to try to figure out the frequency of perceived odors in a given area that is affected by this pollution. But usually these type of studies are done by the industries or by environmental authorities, so they are private, and usually citizens do not have access to this data or environmental information. Many of them are concerned about health issues, like they do not know what they are smelling, how it can affect their health, for example. And also because of the complexity of measuring odors, this is an under-regulated issue. And in many European countries, for example, there is no national regulation, there is no common European framework, for example, to regulate odors. And in many cases, the regulations, when they exist, are heterogeneous. It's not, even though it's similar to noise, it's much more complex to measure the odors. That's why also regulating odors is quite complex, and that's why they are under-regulated. This is a map of the existing regulations worldwide. Most of them use dynamical factometry, so the first methodology that I mentioned. But again, as you see in the map, in many countries, there's still no regulations, and most of the citizens affected by the pollution are unprotected. So we were thinking how we can change this, and taking into account that the nose is the best sensor to measure ambient odors, and that our acuity or the ability to smell a certain odor takes this distribution that you see here in the graph. We thought that why don't we change the paradigm and use our noses to map odors anywhere at any time when we perceive them, so that we can change also this concept of complaining to make real-time odor observations, to start monitoring. And this is how the idea of applying citizen science to monitor odor pollution came up. And having said that and introducing this, I would like you to take a small interactive exercise for waking you up. If you go to slido.com and you type on this number, you will find some questions there. I will put it in the chat, and probably Joanna will be sharing the results. Is that correct, Joanna?
Yes, correct. Where I will share my screen. Okay. You can see my screen?
Yeah.
It's also on the chat now.
Yes, so you need to go to slido.com and type this code. I will do it as well. Are you all inside? Does anyone has any problem to enter the Slido? Okay, I hope not. So Joanna, I cannot see the question now. I don't know if you can see it.
Yes. The first question is this.
Now, perfect. So the question is, how do you think citizen science helps to better understand the odor pollution problem? It's an open answer, so just feel free to express your opinion on the issue. Mm-hmm. So is it true that the citizens have the local knowledge? So they really know very well which smells are present in their daily lives? Collecting data about the areas where odor is an issue and reporting of how much of a problem it is to local citizens. Exactly. We can understand how they are affected by the issue rather than assuming. Exactly, because yes, in the traditional methodologies, you are estimating the impact. Citizens are the main actors, so an important part of the issue and possibly of the solution. Citizens will know how the pollution situation has changed over time. That is also true. Okay, very nice answers.
Okay. The next question.
Yeah. In your opinion, what are the most important contributions that citizens can make to monitor odor pollution or other environmental issues? How can they contribute the most? Local guidance and history of the issue, totally right. They live there, so they know. Local knowledge, which is used as evidence for policy making to tackle the issue. Gathering valid data on the issue, sharing their knowledge. Breadth of time and space they can cover. Yeah, totally true. Instantaneous reporting. This is really important because this is what we manage to do with citizen science that it is impossible to do with traditional methodologies. By letting know local issues that scientists may not be aware, contribute data regularly, they can register the odors, alert the authorities or the emission sources. Perfect, you are masters of citizen science.
Yes.
Share their feelings on the issue with each other, exactly, while collecting the data also. They can provide local knowledge and data that otherwise is unknown to scientists. Yes, you are totally right. So let's go to the last question. We will show you our work. What are the benefits of using apps to contribute to environmental monitoring?
Yes.
Consistency, real time. Yes, consistency is also important because usually in odor pollution, a lot of surveys were used on paper. So then you have a lot of consistency issues when you just translate the data into the computer, for example. It is not perfect. It makes data contribution easy, for sure. Accessibility as well, collected more data, quick and easy collection of data, more local data on areas experiencing problems. Yeah, you mentioned the disadvantages on relying on technology. This is true. There are a lot of advantages, but We also consider this to be inclusive and, for example, use paper diaries in areas where people cannot use or access the technology. Geolocation, yes, exactly. Perfect. I think that that could be enough, Joanna. Thank you very much. And thank you all for your contributions. But you are citizen science experts, so thank you for this, because in other audiences, the answers are not so clear. So let me go back to my presentation if I can find it here. Yes, and share again my screen, and we will show you what we managed to do within the Gnosis. Okay. Perfect. So this was the panorama before we started to apply citizen science, and other people such as Sofia, as she will explain later, with the traditional methodologies, and we place citizen science here. In the receptor point of view, we are gathering data from the receptors, not from the emitters, but from the receptors, and we are using the human nose, so still sensorial measurements to monitor this pollution. And as you mentioned, for example, this allows for real-time odor monitoring, for to take into account the real perception of citizens, so the real impact. Also, risk of bias information is easily addressed through data plausibility techniques, as you mentioned as well. And we are also changing the approach from the top down to the bottom up, and involving citizens, of course, in the issue. So that's how we started developing Odour Collect, which is a free app that is available for Android and for iOS. I encourage you to download it and test it and start mapping odors in your neighborhood. You can map nice smells because of a citizen's request. But the focus is on odor pollution, so you will find a lot of types of odors related to waste management, industrial odors, urban odors, etc. It is very simple to use the app. It is in several languages as well. And what you need to do is the app geolocalizes you, so you don't need to state where you are, etc. But you just need to report the type of smell, the subtype of smell, if you know it. Of course, this is not so simple, but we train the citizens that we involve in the project so that they can distinguish and especially name the smells that they are perceiving on their neighborhoods, and also the intensity and the hedonic tone, which means how much you like or dislike the odor that you are perceiving that is related with the nuisance. And this is how the idea of the Gnosis started. It was a European project that lasted for 3.5 years, starting in 2018. So it finished last September. And what we wanted to do is to raise awareness, provide access to information through the International Odor Observatory that you can also access if you want. Also to validate the methodology, the citizen science methodology to monitor odor pollution through 10 local case studies, and also produce several documents to inform policies, such as the Green Paper or the Strategic Roadmap for Governance that are also publicly available. We also wanted to inform evidence-based policies, as this is an underregulated issue. So we wanted to contribute to the compliance of Principle 10 of Rio Declaration that advocates for access to environmental information, access to environmental justice, and public participation in decision-making. And we believe that citizen science goes one step beyond, because citizens cannot only access to environmental data, but they can contribute to generate this data. We work a lot on the policy side, running, for example, policy societal dialogues. I don't want to bore you with all this, but you will find all the documentation available in the project website or the International Odor Observatory. And we work using this multi-level governance and engagement model, because in the countries where we were working, we were 9 in total. We started at the national level by understanding the policy context, the competencies for regulating odor pollution, mapping affected communities that are a lot, and you can find in Google, in the newspapers and everywhere cases of communities affected by odors. Then from there, we selected the exact location for the pilots to validate the methodology. And from the results of the pilots, we went global and produced the final reports and documents for the project. Probably you are super familiar with this graph because Mapping for Change is one of the partners of Diagnosis. And as you know, this extreme citizen science model was born at UCL, so your research group. So we are not showing you anything new, but this was our inspiration. And what we did was to adapt this extreme citizen science model to the mapping of odor pollution and our citizen science methodology. And we increased a little bit the number of phases. And also we wanted to work with a highly inclusive engagement model, so involving everyone with any literacy level, any gender, or any socioeconomic or sociocultural background in the monitoring of odor pollution, since we all have noses, so we are all able to monitor odor pollution. This is the framework more in detail, but I will show you better now with the example of the pilots. We will be sharing this presentation with you, so if you have more questions or want to know more details, you can ask. This is where citizen science, co-creation, and also inclusivity takes place through the project. These are the 10 pilots. We were working in Barcelona to start with. This is one of the examples I will provide. In UK, also Mapping for Change ran one pilot in London that I will show you later. And also we're working in several European countries and also Chile and Uganda. So we were using Odour Collect, and these are, for example, the results that we obtained in Barcelona, which was the first pilot where we tested first the methodology to adapt it to the rest of the pilots. And we gathered 600 observations with 86 neighbors involved. Just very briefly to explain you where we were working in Barcelona. These are some of the pictures of the pilot. You see here, well, we selected the area because it has a lot of emitting activities. So waste incinerator, waste treatment plant, wastewater treatment plant, and a sludge treatment plant from the sludge coming from the wastewater treatment plant. So a lot of sources there. And also the social reality was quite complex because the area used to be a depressed area, as you see in the low left picture, but it was refurbished and the new buildings were built, conference centers, nice hotels, a nice harbor, etc. But the other emitting activities were still there. So all these, the old and the new neighbors were equally affected. These are some more pictures of the activities, but I will probably skip this part because we will run out of time. These are the old wastewater treatment plant that was covered with this nice square that you see here, where the forum of the cultures took place, and you see this nice conference center there, etc. And then we started the pilot, so launching all these 8 phases that came from the adaptation of the extreme citizen science model. So first of all, we started by identifying the problem and doing some stakeholder mapping to understand who we wanted to involve. For us, it is very important to work with the quadruple helix model because we want to involve, of course, citizens on the monitoring, but also the city councils affected and the environmental authorities in charge of the problem, and also the other emitting industries, together with the experts, both in odor pollution and also in citizen science. So we have a huge map of factors to get involved. Then we start doing some ethnographic research to talk with the neighbors and start understanding the problem from their perspective, not from our perspective or the desk research perspective, but from the real experience. And we started recruiting participants also and having the first conversations with the neighbors. Then we start to run a pre-pilot that we call, because as I mentioned, this was the first pilot that started everything, and we wanted to test the methodology with a small group of citizens first to see how it worked, to see the first data collected, to see if it fits or not what we were expecting. And then we increase the number of citizens participating. So here we have around 15, 20 people involved, where we were meeting with them to try to understand the issue, doing sensory walks, for example, for training, so naming the smells that they were perceiving. We started the data collection with them. We ran interviews to get their feedback and see if the app was working well, if they were mapping correctly the different types of smells, etc. And we analyzed the first data. Once we thought that everything was fine, we launched the next phase, and we increased the number of participants up to these 86 people that were reporting at the end. And this onboarding was constant, although we have some affections due to the pandemic. As you see here, we still are not wearing masks, but then we're starting wearing masks at the end. So these are the results. I don't want to bore you very much with the technical things, but just to let you know that we were really surprised, because these are the percentages of the odors perceived in the affected area. And you see in the first graph that 52% of the time the neighbors smell wastewater. 27% of the time they smell waste. And this was totally what we were expecting, because we ran in the past traditional odor studies, and we knew that the wastewater was the main emitting activity there. So we were expecting this type of percentages, but they were also stable from the beginning. So from the pre-pilot phase until the very end, they did not change. So this shows a huge consistency of the data collected by the different neighbors, even though at the beginning we only have around 15 and at the end we have 86, but the percentage were the same. This is the intensity, this is the hedonic tone, and just for you to know that we saw that even though the wastewater odors were perceived more frequently, usually the waste odors were perceived as more strong and with an hedonic tone more unpleasant. So probably they are less frequently, but they annoy more the population when they perceive them. And also we were studying all the perceptions, the observations per hours. So we saw this peak during night. Of course, this is related to the people, diurnal activities. We saw a drop on the observation at night because, of course, we are all sleeping usually, so we don't have other observations. But especially from 19 hours or so, we saw this peak. And we started analyzing by type and subtype of odor to see why this was happening. And in fact, we knew because the neighbors told us, and because the previous studies, the other studies told us as well, that from that time, the trucks carrying out sludge coming from the wastewater treatment plant start the circulation, and they were causing the biggest odor problems in the area. The sludge is really smelly. I don't know if you have smelled it, but it's super smelly and really unpleasant. So this was reflected also on the data, and the peak was disappearing as the people went to sleep, not because it was not disappearing. I will go quickly on these graphs, but just to let you know that the more you analyze, the more you can see the peak and the activity of the trucks. And also, this is the classification of the observations by seasons. And of course, you know that in summer, usually because of the high temperatures, you have more odors. This was also reflected in the data. So it was also, again, consistent. And also, we were analyzing daily odor episodes for the different types and subtypes of odors. And again, sludge was the subtype identified with more odor episodes. So to summarize, all the data were really consistent. And well, I will go very, very quickly with this. This is the location, but you will see it better of the observations in Odor Collect that, as you know, they are geolocalized in relation to the activities. And you see that the wastewater odors are more or less in this area, which is very close to the sludge and wastewater treatment plants. And the waste treatment, the waste odors are more dispersed in the territory, but are also closer to the activity. Then we run a lot of visualization with the donic tone, etc. And to conclude, we were very happy because this pilot allowed us to monitor the other impact from the receptor's point of view. It was consistent, it matched the results with the traditional other studies. We could see the activity of the drugs and identify the situations of maximum impact. So the next step would be to correlate these observations with the industrial operations so that they can reduce these situations and that's the impact over the population. And finally, very, very quickly, I will show you the pilot that was done in London by Mapping for Change. In this case, they were working in this area in London because there was an asphalt plant, which was the main emitter, and also some former gas works that were emitting some smells from time to time due to the construction works. You can see here the engagement that, I mean, the same phases of the pilots were applied, we were doing the recruitment as well, etc. And you see here the data collected. And what I would like to highlight of these pilots is, of course, the environmental authorities, the local authorities were involved as well in the pilot. And it was really nice because due to all these conversations they had, they said, we find this super useful for us, but we really need to know or to have an alert to let us know when these others are happening so that we can act. So because of that, we implemented these email notifications in Odour Collect. So you can set up, for example, when you have one observation or 2 or 3 observations in a period of 2, 3, 4 hours, you can select the type of odor, etc. Then when this happens in Odour Collect, automatically you receive an alert that this is happening. So if you are on field because you are the industry or the environmental authority, you can check what is going on and what is causing this smell, and maybe reduce it or do something about it. And also because they like so much this methodology and they saw the potentialities, they decided to hire an environmental protection officer specifically to deal with this other complaints. So this was a huge achievement from the London pilot. And just to conclude, as you see, the proposed methodology allows us to monitor for the first time in real time the other perception, but from the receptor's point of view. So you can create or co-create with the citizens, even or the local authorities or the industries or all together, other management plan that deal directly with the situations of maximum impact. You can also understand how, for example, systems or measurements to reduce the emissions or the impact are working, if they are working well or not, so that you can see the changes in the perception. You can manage industrial operations better to reduce the impact. And of course, you promote transparency and, well, the relationships with the communities and everybody else. So I will stop here. I know it's very, very late.
Thank you so much, Rosa. That was a very exciting and interesting project. And I do hope that the people who joined us today and who don't have any knowledge of how to set up a successful citizen science project, that would give them a lot of insight of how to start from the beginning to the end. And also how obviously important is the data that you can get from, you know, the data that the volunteers collect. So thank you very much. Do you want me to add your Twitter handle on the chat so that people can use Twitter to ask you any questions?
Yes, that could be super nice because I have to run to pick up my son from school, but I will be answering questions later. Or Joanna is here also; she can answer any questions.
Okay.
Thank you so much for the invitation, and sorry,
you.
Sofia, for missing your talk.
Thank you very much, Rosa. So we will now move to our second speaker for today, whom I introduced earlier. It's Sofia Teixeira. And as I mentioned, Sofia is a research fellow in air quality group of the Department of Environmental Sciences and Engineering from Nova School of Science and Technology in the University of Lisbon. And Sofia is also an expert in the concept of in the area of atmospheric odors, developing odor monitoring programs, and she also has been involved in air quality monitoring campaigns and environmental awareness actions. Sofia, over to you.
Thank you so much. Thank you so much for the invitation. I will share my screen. As you already heard Rosa talking, we also do sensory evaluations on odor monitoring with the methodology that we have been developing in recent years, that are the observer panels, that are groups of citizens who participate in our studies and help us to analyze data and produce data that are vital for the analysis. So first things first, and because sometimes we are not aware of what are atmospheric odors or environmental odors, they are a set of substances that when mixing in ambient air can cause reactions of pleasure or unpleasure in humans. They manifest themselves by inhaling volatile compounds through the human nose. Even in very low concentrations, our nose is very sensible, and it has the capacity, the ability of trigger a reaction from our side. The others can be dispersed by neighboring populations that are sensitive receptors, and they can trigger complaints. Why do we perceive the environmental odors? Well, our human nose can detect 10,000 of different types of odorous compounds, and it's the best sensor for evaluating odors. We can perceive them in very, very low concentrations. And although we can perceive that very low concentrations, sometimes they don't have chemical components in their compositions or high levels of toxicity, but also they can affect our health, as Rosa said, by the discomfort that they can make us. How can we evaluate atmospheric odors? Well, this is one of the most difficult environmental parameters to characterize. We, in Portugal, where I stand, don't have any legal limit value, only a reference on the air quality article of the decree law. We know that environmental odors and its dispersion changes according to meteorological conditions, for example, the prevailing wind direction. And we know that odors can reach neighboring populations, which can trigger complaints or complaints processes. Then the main sources of odor can be, for example, livestock or industry odors, like the refineries, the landfills, the food industry. It can be urban odors, results of human activities, and we also can find them in nature. We have the smell of the gardens or the fires, forests, etc. Here in Portugal, we have several emission sources, but we also have many mobilized groups for action. We have many associations, environmental associations, citizens associations, social networks. Here are some examples that are a result of the newspapers and of the Facebook groups reporting the discomfort of bad odors. We have odor problems in the community, so how can we resolve them? We have multiple sources of odors. We have citizens' perceptions, because everybody has its own nose. We can have a constant evaluation of environmental odors. Sometimes we have lack of knowledge on the subject. We also have lack of legal obligation to act. This could rise to emerging conflicts. And how can we have a response to this case? with a combined collaborative strategy. We emphasize the collaborative methods with a bottom-up approach, with these observer panels that we are going to see next, with the sensory evaluation using the human nose as a sensor and with field of photometry. But we complement this with the analytical method, the traditional method, the top-down approach with quantitative evaluation, with field inspections, and with atmospheric dispersion models. So these observer panels are no more than a network of voluntary persons without connection with each other, without any connection to industrial operations or operators in the area, that are emission sources of odor, and with the common characteristics of regularly perceiving some type of odor in the atmosphere in their places of residence or in their places of work. By gathering these elements, we have on one hand citizens' engagement, on the other hand we can promote an active citizenship, and we have the potential to resolve the conflicts. This collaborative data production with these observer panels has the power to, on the one hand, we can give people the intention to participate. They are motivated from an environmental problem, but we could provide them knowledge on the subject. We can mobilize them for action with the recording of odors in ambient air, and we can make them part of the results by achieving an odor mapping on the analyzed territory. The purpose of the formation of these groups, besides to the complement of the traditional methodologies of analysis, are the mapping the different types of odors existing on the area and assess their degree of dispersion, providing information experienced by the main actors in their territory, allow to gather a set of important data for industries, for stakeholders, for the citizens themselves, and allow us to work in depth at the local level, at the local of the community, the municipality, the parish. That sometimes isn't easy to do. So how can we form these groups? Usually we use all the available contact techniques to ask for collaboration. We post things on social media. We use our own databases. We go to commerce and services of the area. We disseminate the purpose of the project on our own platforms. Use predefined mailing lists, and if we know that are some citizens that are claimants, we will invite them to participate on these studies. After a simple registration, we select our sample by giving them a survey, and this sample is the result of the participants being interested on the project, identify themselves with the objectives of the project, be available, and do this pre-register. After we select the sample, the participants are informed of what will be their active role, and the task usually is to create a register of atmospheric odors during different meteorological periods, during summer and during winter. How do we do that? We don't have an app, but we have a grid that we give them, or we have created a Google form that can be accessed by a smartphone, and on which they could do real-time monitoring by registering on anywhere of the study area their odor records. In order to form these elements, we give them some characteristics for them to simply identify if they are in the presence of an environmental odor. These characteristics are the frequencies. How many times do I perceive the odor? The intensity, is the odor strong or weak? The duration, does it last a few minutes? Does it last some hours? The offensiveness or the hedonic tone, is it nice? Is it unpleasant? And the location, where am I when I smell it? These are the essential characteristics to analyze these odor records. How can we maintain these elements through all our studies? Well, this is very hard, and sometimes it's just like an impossible thing to do, but we have to have some actions in order to maintain them, how can I say that, engage with all the process. We have to establish communication between scientists and the elements. We have keep them informed in all the tasks of the project. We have to provide them feedback on the group situation and the results that are being achieved to keep them motivated. We have to share some scientific knowledge on the subject, this is a very important thing. When we have to be available for any question, any clarification, any doubt that can arise. Sometimes they emailed us some doubts or some kind of orders that they didn't be able to recognize, and we have to be available for all of that. The types of communication that we usually use are phone calls, are conversation applications like WhatsApp groups, email, and sometimes face-to-face. So these combined strategies that we usually use with the help of this observers panel make us achieve thing that is very important in this kind of studies that are validation of the data. So on one hand, we as researchers have to have input data on meteorological parameters, on field inspections, on simultaneous odor records in different locations, but at the same time, the data reported by the citizens help us to validate this data that we have produced earlier. So this is a very important thing. So just to give you some example of the replicability of the results with the observers panel's collaboration, we have here a study that we developed in Almada municipality that regards cereal processing food industry that has some impact on the population that live nearby. And we have been doing this study in different phases. One phase occurred in 2015, 2016, and the second phase occurred in July to September 2019 to February to May 2020. We had an observers panel that have collaborated with us for 440 days of activity. As you can see, we had people in the gender, feminine gender that are most of the participants, and we have 25 to 54 years old of age distribution with the 19 volunteer citizens. On the first phase, in 2015, we had 355 other records, but on this second phase, on 2019-2020, we have only 87 records. This is the result of some measurements that were applied by this food industry to minimize its impact to the neighboring population. As you can see, the distribution of records by odor, we have 51% of cereal flour feed type of odor perceived by this observer panel. And if we attend only to the second phase of this study, we see that we have most or higher number of records in September of 19 and a high decrease of all the records during the first COVID-19 confinement. And here I think people were a little bit more worried with the COVID and with the pandemic situation than with the other records, because this food industry didn't stop its work, and I think the other was still with some impact on the population. So we see here, and with the validation of the data, that the elements of the observer panel reported that most of the odor were made to the east and southeast of the emission source. That was the coincidence with the predominance wind direction. DOP volunteers made their weather description at the time of the records, which was coincident with the data collected at the weather station that we placed in the operator's deployment area. And the data produced by these elements of the observer panel were also validated with the information collected by the technical team through the bottom-up approach methodology. We have been doing several case studies involving citizens and different other problems, like the cement, the urban solid waste treatment plants, landfills. So since I think 2015 from now, we had 10 observers panels, 136 volunteers, and 818 other records at total. Just a note on this collaborative approach with the citizens. We think the main thing is we have this public involvement with science and institutions. We can provide knowledge on the subject, which is much important, and the other problems, because we can access decision-making more rapidly. This is a high cost benefit. It creates a diversity of data. It is very closer to local reality with this approach, but we do not, we should not consider volunteers as labor in the collection of information. We have to maintain the involvement, the enthusiasm, the accountability of the volunteers, and we have to make sure that the data that we collected are valid, and we have to validate them. So thank you for your attention, and if you have some questions.
Thank you very much, Sofia. Again, I would like to thank Rosa and Joanna for helping here, and everyone who joined the session today.